You know, there's this invisible line that connects all of us. It starts with something simple, like flicking on a light switch, but it ends deep in the chemistry of our oceans. Today, we're exploring that very line, the carbon connection, and how the way we power our lives is reshaping the planet itself.
So, let's start with a question for you. Think about your day so far. The food you ate, maybe the car you drove, or even just the air you're breathing right now. What's the one thing that connects all of them?
And there it is, carbon. Every one of those things plugs you directly into Earth's huge, incredibly complex carbon cycle. So in this explainer, we're going to follow that thread and see exactly where it leads.
All right, first things first, before we get into any of the changes, we have to understand the baseline, the natural, balanced system that's been running on Earth for millions and millions of years.
It all begins with the sun. I mean, it is the ultimate engine for our planet. It powers our weather, drives the currents in the ocean, and fuels the photosynthesis that creates the food for pretty much all life. Think about it this way. The energy in your last meal, it started its journey 93 million miles away.
And the fundamental building block for all of that sun-powered life is carbon. You know, NOAA calls it the chemical backbone of life, and that's a perfect way to put it. It's in the air, it's in our food, it's in us, and in its natural state, it just cycles around and around between the air, the oceans, and all living things, keeping everything in a really delicate balance. And just to give you a sense of the sheer scale we're talking about here, get this. The ocean holds about 50 times more carbon than our entire atmosphere. It's this massive, massive reservoir that acts as a critical buffer, helping to regulate everything.
So you've got this beautiful, balanced system, right? But then a new catalyst enters the picture, one that starts a total revolution in how we humans get our energy.
You know, for almost all of human history, our energy came from burning stuff that was, well, recently alive, like wood. But then the Industrial Revolution hit, and we figured out how to tap into a completely different kind of energy. Ancient, super-concentrated carbon that had been locked away underground for millions of years. Coal, and then oil and gas. This was a monumental shift from living carbon to fossil carbon.
And the impact of that shift is, well, it's just staggering. Look at this chart. For over a century, energy use is pretty much flat. And then, right around the start of the 20th century, bam! It just skyrockets, and it's almost all powered by fossil fuels. By 2010, our energy diet looked like this. A whopping 83% came from fossil fuels. We had effectively built our entire modern world on this ancient, stored-up carbon.
So, what happens when you take millions of years of stored carbon and release it all in just a couple of centuries? Well, you kick off a chemical reaction that starts to tip the planet's natural scales.
And here's the absolute key to understanding this. It's all about speed. Naturally, that carbon would be released over millions of years, but by burning fossil fuels, we're releasing that same amount in just decades. We're pumping it into the atmosphere way faster than the planet can naturally absorb it.
So all that extra CO2 has to go somewhere, right? Well, a lot of it ends up back in that giant ocean reservoir we talked about. But there's a limit. As the ocean soaks up more and more carbon dioxide, it kicks off a chemical reaction that makes the water more acidic. This process is called ocean acidification. Now, these numbers might not look like a big deal. 8.11 down to 8.04. But because the pH scale works in a funny way, that tiny drop tells a huge story. It actually represents a nearly 20% increase in acidity in just a few decades. That's an incredible chemical change in such a short amount of time.
Okay, so this chemical change in the air and the oceans, it doesn't just stay there. It kicks off this massive ripple effect, leading to very real, very measurable consequences on land, in the air, and for the ecosystems we all rely on.
Let's just look at a few examples, right? Think about this. The 10 worst years for wildfires in the United States in terms of sheer area burned, every single one of them has happened since 2004, as warmer, drier conditions become more common.
And it's not just on land, the same thing is happening in our rivers. In the Snake River, which is a critical home for salmon, the water has warmed up by 2.2 degrees Fahrenheit since 1960. For a cold water fish like salmon, well, that kind of change can be absolutely devastating.
So the environment is changing, and the animals? They're literally voting with their fins. Marine life is on the move. The average population has shifted nearly 17 miles north, and some species, like the American lobster, have migrated over 145 miles, desperately chasing the cooler waters they need to survive.
And really, this is what it all boils down to.
On one side, you have this intricate, balanced natural system. On the other, the powerful industrial engine we've built. And all the data we've just seen, it shows the consequences of that connection.
You know, this quote from the EPA just hits the nail on the head. The key word here is faster. Life has always adapted, sure, but the pace of our impact might be pushing ecosystems beyond their ability to keep up.
Okay, so we followed this thread all the way from a light switch to a lobster moving up the coast. So what's the big takeaway here? What does this all mean? Well, it all comes down to a single, really powerful idea.
It's called energy literacy. And look, it's not about memorizing complex physics. It's simply about understanding the exact connections we've just explored, knowing where our energy comes from, how we use it, and what its consequences are. That understanding is the foundation for making informed choices.
And that leaves us right here with this final question. We've seen the connection. The science traces a pretty clear path from our energy choices to a planet that's changing rapidly. So the question isn't really what's happening anymore. The real question is, what are we going to do with that knowledge?